So hi girls again. So in this animation, I'm going to show you the difference between a DC circuit and an AC circuit. So we've got a simple, this is a battery, a DC battery, a lamp and a switch. And on this side, we've got an AC battery, a lamp and a switch. Oh, sorry. And if I could give you in symbol form, so that you can see that's the battery and that's the AC battery and so on. I will change it back over here. Okay. Now, so let's see what happens. We already know what happens in this one. So let's turn the switch on. So the current starts flowing and current becomes constant instantly. Okay, so current flows only in one direction. It's just going back and forth. We will call it just charges, a neutral word. Okay. Let's look at what happens in an AC circuit. So I will just close the switch. Now, if you look over here, so if you can see those charges, they're moving in one direction and then they move back in the opposite direction. And the lamp is kind of flashing. And we will talk about that why it is flashing. But nonetheless, current is moving back and forth and the lamp lights up. So let's open this one for a minute. Now, if we look at how does the current and voltage change in a DC circuit? So this is the current time graph. And this one over here will show you the voltage time graph. So as you could see that initially current was 0 before I turn the switch on. Now current is about 1.5 and voltage has got some value that is between 10 and 20. I will just make this about more than 12, maybe 14 or 15. I had these two batteries at the same voltage. So current and they're constant. Let's see what happens in this one. Okay, so now we will have this current time graph over here and then voltage time graph over here. Okay. So as you can see from here, that current is not only, so this is, when current is in this part, that's the positive current. That means current is flowing in this, say, in one direction, and this negative signal says that current is flowing in the opposite direction. Somewhere over here in the middle, current is 0. So current is not only changing direction, but it is also changing the size, and so is the voltage. Just make it a little bit bigger. Okay, now if I just stop it here, you will be able to see that current and voltages, they're becoming constant at the same time. Let's see. Okay, now if you look over here, at this instant, at this particular time, current is 0 and the voltage over here is 0. And at this instant, lamp is not lighting up because there is no voltage and no current through the lamp. So therefore the lamp goes off. Let's start it again. And this time I will try to stop it when the current, and somewhere over here, you can see that current is maximum, so is the voltage. Voltage is maximum and lamp is going at its full brightness. I will stop it and start it again. And now current is negative, so is the voltage, and the lamp is going at its full brightness. Or in other words, what we are saying is that lamp lights up when the current and voltage is their maximum, or when current and voltage is their negative maximum. And another thing that we can see is that current and voltages, they become positive maximum or negative maximum at the same time. Or in other words, what we say is that current and voltage, they are in phase. Is everyone following so far?
Yeah.
Okay, that's good. Now this time, what we're going to look at is what happens if I change the frequency of the supply. So this is an AC source or AC battery. There are different words which are used: AC generator, AC supply, AC source. So let's change the frequency. So I will change the frequency. So presently, frequency is 0.5 hertz. And 0.5 hertz means that it makes half a cycle in 1 second. That means if current is 0, it becomes maximum, and then it becomes minimum. And then it goes from negative minimum to negative maximum. So that's what the frequency is. So 0.5 hertz. Let's change the frequency to maybe 1 hertz. Done. And turn it on. Do you see that, this graph has become closer and the lamp is kind of flashing faster? Do you notice that as compared to before? So frequency has increased, and so both voltages and current, they're changing more faster or more quickly, and the lamp is flashing faster. Now, if I change it increase the frequency even further, change frequency. So maximum I can do is 2. So I will make the maximum. And as you can see, that frequency has become, they're quite high, but the lamp is still flashing. Now, in household supplies that we get at school or at home, the frequency is 50 hertz. This one over here is 2 hertz. That means it's making 2 cycles every second. And 1 cycle is from here to there. I will bring that one back up again in a minute. So the lamp is flashing, and that's the reason they don't flash. So at 50 hertz, lamps still flash, but they flash so fast, or the flickering is so quick that our eyes cannot judge it. But nonetheless, they're flashing because they are, this frequency is very close, so we can't detect it, but nonetheless, they're flashing. So 50 hertz is a frequency at which we won't be able to see the lamp flashing. Okay, let's change it back to what it was before. Say somewhere 0.5 hertz. Or maybe I will make easier, will be 1 second. So I will change the frequency to 1 hertz. Okay. Okay, now, so presently frequency is 1 hertz. That means current and voltages, they're making 1 cycle. And what is 1 cycle? 1 cycle is if I start from here, so that's 1 crest and that's 1 trough. So that is 1 cycle or 1 hertz, or we are saying frequency is 1 hertz. So in this graph, if we look, so from and as you've seen, if there are more of these cycles, that means frequency will be higher. And if there are less of these cycles, that means frequency is lower. Now, another thing is that we can also change the current and the voltage. So if I change the voltage of this one, so presently it is 15.29. And let's say if I make it a little bit higher for 20, done, and start it. So now you can see that lamp is flashing faster, and this graph, you can see that current has increased and voltage has increased. I will just stop it somewhere over here. So, okay. Okay. So this one over here, from here to there, from the mean position up to there, that's the maximum current. Okay. From the mean position here is the maximum voltage. And in a minute, we will talk about that. What is the difference? Another thing that we will be learning is what's the difference between peak voltage and RMS voltage. So that's the peak voltage here, and that's the negative peak. That's the positive peak current, that's the negative peak current. So if I will just leave that screen and come back to my notes. Okay. Do you all see the notes on my screen?
Yep. Yes.
Okay, that's good. Okay, so we've already talked about that. That's the voltage and current. They're constant in a DC circuit and they're changing together. And that means when voltage current is maximum, voltage is maximum, or they are in phase. Okay, we've seen all that. So just over here, some formulas to look at in this one. So from here to there is the peak voltage, and it is true for the voltage time graph or the current time graph. And that's the negative peak voltage over here. What is period? Period is how long does it take for the current or voltage to make one cycle. And what is one cycle? It is from here to there. And what's the relationship? So frequency is 1 over T, or T is 1 over F. Now omega is called the angular frequency. And so what do we mean by angular frequency is when alternating current is generated. Then remember in the class I showed you a demo when I was spinning a generator and the lamp was flashing. So what was happening was there's a coil which moves in a magnetic field when the wheel is turned. So how many rotations does the coil make? That will determine this one. So say, for example, if it's making one frequency is 1 hertz, so that means it's making one cycle. And in one cycle, the lamp lights up over here and there. So in each cycle, lamp is lighting up twice. Once here when the voltage and current are maximum, and once the voltage and current are negative maximum. So formula is same as we learned in simple harmonic motion. We've already done that, but angular frequency refers to that generation of how that AC current or voltage is generated. So there are some notes over here that you can read in your own time. There are some videos that I have loaded up here. This is quite nice one, which is actual activity where you can see what happens when the frequency is about 30 or more than 30, about 50 hertz, lamp stops flashing. It will be just going, it will appear as if it's going constantly, but nonetheless, it will be flashing. Okay, and there are some videos here that you can watch those one. Let me see, another thing that I want to look at in today's lesson is, okay. Okay. Okay, so now coming back on this one, if this is a DC circuit and this is an AC circuit, so the graphs look like this one for an AC one. It could be voltage and current. So the blue line is showing you the current or the voltage time graph. So remember, the lamp flashes here and lamp flashes here. So the lamps are getting energy or power, which is voltage time current. So it will be over there. So it's not that if the voltage is negative or current is negative, there will be no brightness, or there will energy will still be used up by the lamp. It doesn't matter, current goes this way or that way. So how do we compare, because current is changing all the time, how can we compare it with the DC voltage? So we use a word which is called RMS, or it's an abbreviation for root mean square. So power in a DC circuit is voltage time current. In an AC circuit, power, which is the measure of the brightness of a lamp or how much heat does the resistor produce, that is RMS voltage and RMS current. Now, how does it relate? RMS one, so maximum current is this value, or the minimum current is this value. So somewhere over here, we say that's the RMS value. and RMS value is the same or it is equivalent to a DC voltage or a current. And what's the relationship? We will be, you can look over here in this video, but that's the relationship. So remember that peak voltage will be greater than the RMS voltage, and RMS voltage is equivalent to a DC voltage. So formulas are VRMS is equal to V peak divided by square root of 2, or IRMS is equal to peak current divided by square root of 2. Okay, so that is kind of, any questions about this, these set of diagrams or notes? And it's a new concept, girls. So obviously in first go, it may not you may not completely understand it, but there are some activities that I have put in, and you can set activities just like I wired up the circuit. You can wire up connect the circuit and then just change the values and see what happens. So let me just stop sharing the screen so I can go back. Okay. So any questions, guys? All good? Yeah.
So the RMS value, is that like maximum value of the voltage or current? Or?
No, so RMS value is only for the alternating current. And alternating current is constantly changing like a sine wave, like this one. Okay. So overall, we say it is equivalent to a DC voltage. So RMS is like, it's an AC one. So you always have to remember that it's a changing voltage or changing current. But what is in terms of, if we want to give it one value, which is equivalent to a DC value, then we call it RMS.
Okay, yeah.
So, and you know, like even the formula, like when we use it is R equals V over I, that's Ohm's law. So if you're using voltage as RMS voltage, then current should be RMS current. If you're using the voltage as peak voltage, then current should be peak value. So for all the formulas that in electricity, they are true. So in AC circuits, all the formulas will be used, but we will be using the RMS voltage. You know, like say, for example, in New Zealand, household voltage is 240 volts. We call it as 240 volts, but it's actually, it's an AC, so it cannot be constant 240 volts. What it means is that if the lamp at your homes, it's lighting up, it will give you the same brightness if you connect it to a 240 volts DC supply or DC battery. It will have the same brightness. But actual value of the peak value, so AC, you know, supply in New Zealand is 240 volts. So how much is actually, so if we do 240 and peak value will be greater times square root of 2, it comes about 340 volts. So what it means is that household supply in New Zealand is changing between plus 340 volts, then negative 340 volts. That's how it is changing all the time. But overall, in RMS value, it is called 240 volts, which is same equivalent to a DC voltage. So all your appliances, you know, whatever is working, it is working on 240 volts. And if you connect your lamp to 240, or you connect your stove to a 240 volt DC battery, it will give you the same amount of heat as it is giving at, you know, the town supply. Does that answer your question, Sophia?
Yeah, thank you.
Any other questions, girls? Okay, so if there are no more questions, then I will let you get on to your work, today's lesson. And thank you for joining in again. And if there is another meeting required, so just please keep an eye on if I send you an email. So if I think that you require another meeting, then I will just call another meeting. Is that all right?
Yes.
Yeah.
Yep. Good.
It will be during your physics scheduled time. It won't be kind of an extra time, but we will see how it goes, you know. And if there are any questions or queries, feel free to just send me an email and I will try to explain. Okay, thank you, girls. And that was all from me, and hope the week goes well for you.
Thank you so much.
Okay.
Thank you, Ms. Khan.
Thank you.
Bye-bye.